Okay, so welcome to the advanced programming course. So in this first lecture, or lecture number 8, depending on how you count it, let's first talk shortly about the practicalities on how this course works, which is actually quite simple because this is mostly working similarly to the introduction to programming. And then we're going to continue with the actual topic today. Anyway, the basic outline, it's 5 credits. We start today. There are 7 lectures, 1 per week, usually at Thursdays at 10:15 in the morning, except for tomorrow, obviously. And obviously, so the next lecture is on Thursday next week. And then we have those workshop times where you can go with your computer or without your computer if you want any help or need any help with the exercises. And the same set of teachers we had in the first course. I'm still Erkki. You can reach me by my email, erkki.kaila@helsinki.fi. Or if you have anything about the material or something like that, you can also use this shared email address. There are a lot of people reading it. And if you're in Exactum, you can take a look if I'm in my office, but I'm rarely there. And also, I do have a work phone number, but I don't really use it. Or it's on quite rarely. So the best bet, if you have anything to say to me, just use my email or contact me in Discord. So those both are fine. Yeah, let's ignore this one. So no slide. So what are we doing in this course? We continue on where we stopped in the first course. So in this one, we talked about object-oriented programming for the first 3 weeks. So we start with things like objects and references in this first lecture. So this is basically the stuff we already talked about a little bit in the first part of the course, or in the first course. And then we talk about writing our own classes, which is a new thing, and that's what we're going to talk about on the next 2 weeks as well. So next week a bit more about writing classes, having more than one class about getters and setters and so on. And then on week 10 we talk about inheritance, which is a really important topic in object-oriented programming. And then the next couple of weeks, 11 and 12, we talked about functional programming, so about things like list comprehension and generator functions, lump down, and so on. Then the 2 final weeks will be spent with game programming with external library called Pygame, sort of an easy external game programming library for Python. And then on the week 14, you basically write your own game, a simple game with graphics and if you want some sounds and things like that. And then we have the exam. So again, if you know programming, you don't necessarily need to take this course. I mean, if you actually know programming, so we have this initial exam again, meant for people who have previous experience in Python programming and about these topics. So if these seem familiar to you, especially weeks from 8 to 12, the game programming isn't really included in the exam or in the initial exam. But if you know about object-oriented programming and about functional programming, then it might be a good idea to try to pass the course with the initial exam. And the exam is next week, so it's before the next lecture, November 9th, and it's at 12. And again, if you want to take it, send me an email by Monday morning, and then I will send you the instructions on how to complete the exam. Okay, so what do we do in this course? The same principles apply than what we did in the first course. So we have the shared sessions each Thursday, like sort of this lecture-like things, and then you're completing the exercises in MOOC.fi like you did in the first part. So you probably know quite well what kind of workload you need, what's your personal required workload for each week. The difficulty level probably isn't that different from the first course, but again, it varies from person to person and from week to week. So just have enough time to perform everything. All course material is still under the same address. If you didn't do the introduction to programming this year, then register to our MOOC website on this address, programming22.mooc.fi. But if you did the introduction to programming, then you can just continue from part 8. So you don't need to do any additional registering or anything like that. And again, you need to complete the exercises independently, but you don't need to complete them alone, meaning that you can work in small groups or with other students, however you want to. Just don't copy your answers from anyone. And again, please use the Discord to ask for answers. And if you have, especially if you have more, I mean, I think the basic idea is sort of that if you're having problems in individual exercises, then Discord is great. But if you're having more problems, like problems in the general topics, or if you're thinking that you're just not understanding of something, or you find it difficult to get started with the exercises or anything like that, then it's probably a good idea to visit the workshops we have in Kumpula campus. And the workshop times are listed in the material page in the MOOC. We have made some differences after the introduction course based because there are some other changes in the schedule. So check the update times over there, but just remember that it's a great way to ask for help if you're having any problems. So if you did this once already, then you don't need to do it again. If you didn't, then do it now. And again, if you're doing it now, preferably use your helsinki.fi email address and add your student number. It makes registering your grade later a lot easier for me. But as I said, if you already did this for introduction to programming, then you don't need to do it again. Once is enough. And remember to register the course in Sisu. So do it today if you haven't done it already. What else? Then again, the deadlines similar to the introductory course. There's one set deadline for all the exercises or material closes on the beginning of January next year. So basically you need to complete whatever exercises you're working on before the end of this year. And you need to collect at least 25% of points from each round or each part to attend the exam. And then your score is checked on the morning of the exam you're going to take. There will be, well, I'm going to talk about the exams in a minute, a bit more. So to pass the course, again, you need 25% of all points from each round or each part, and then you need 50% of the exam score. So again, try to complete as many exercises starting from the beginning of the course. And the grade is calculated with the same formula we used before. So you get 50% of your grade from the MOOC points and 50% from the exam. And then those are combined, and if you get more than, or at least 90, you get grade 5, and if you get less than 50, then you fail the course. You can always, if you fail the course, you can always take any of the recent exams. There will be at least 2 more than the one listed in the material. There's a first exam will be on Thursday, 15th, but there will be 2 more. We haven't set the exact dates, but I think the first receipt exam will be at the end of January, and then the second one at the end of February. So basically you can, I think it's going to be like the final Saturday of January and the final Saturday of February. If there are no, yeah, I think those are, but those dates will be added to the material site quite soon. Again, you do the exam electronically with your own computer. It's open between 10 a.m. and 10 p.m. and then you can spend the 3 or 4 hours depending on your case during that time, and you can attend as many exams as you like. So if you want, you can participate in all 3 exams, and the best grade is the one that's listed on the, or the best grade will be listed on your study registry. Yeah. Again, remember that all the exercises will close at the end of this year or in the beginning of January, meaning that if you're doing a receipt exam in January or February, you can't collect any points between the beginning of January and the exam date. So whatever points you're going to collect, you need to do it by the end of the year or the beginning of January. What was the exact date? The 3rd or 4th or 4th or something like that. Okay, so I mean, this was sort of like really like a quick introduction because nothing has really changed. It's just the different dates and different topics, but the same basic practicalities apply to this one as well. Do you have any questions about this? Okay, if not, then let's move on to the actual topic of today. The first topic in this advanced course, which is the introduction to object-oriented programming. And now we've been discussing some of the concepts of object-oriented programming before. We've been talking about objects, for example, the fact that in Python, whenever you're storing something into variable, you're actually storing a reference to an object. And probably mentioned that an examples of mutable objects are something like lists and dictionaries, and then we have a bunch of immutable objects like strings and tuples, for example, but also all the basic values like integers and floating point numbers in Python are objects as well. And the thing about object is that they are independent. So what I mean with this one is just, let's look at an example, something like car1. No, let's have something different. No, this is fine, I think. So let's have a model is no, I'm going to change this so I can, sorry about this one. Let's have something like an account1, and the ID of the account is 1, 2, 3, 4, 5, and the balance of account is something like 56 euros and 50 cents. And then we have another account, and these are just our dictionaries. This is something we've done before. We find out that individual dictionaries are great for combining the data of a certain property into a single object. Although today we're going to find sort of an alternative way for that one. Let's have a different ID for this one, and the balance for this one, let's say it's going to be 185 euros. And now the fact that these are individual objects means that well, let's output them both. Something like this, so you can see the data. And now if I change one of these accounts somehow, and this is something that should be familiar to you, let's say no, let's change the balance of the first account to be something like let's add 100, and then output the accounts again, we can see that the balance of the first account has changed, but the balance of the second account remains the same. And this is something that shouldn't, it's nothing new to you. This is something you know already, but I just want to sort of remind you about the fact that we can have sort of similar looking like objects. Like in this case, we have two dictionaries which both have the same keys, ID and balance, but they have different values. And even if they have the same value, those are still individual values. So accessing an item from a certain object doesn't affect any other objects. And now if you think about, well, there's also something else with the objects. There are, I mean, objects contain data, but they can also contain operations. And the operations connected to objects are called methods. So method is basically a function which is somehow connected to an object. So for example, the dictionary objects contain methods such as values, for example, which we can use to output all the values of a single dictionary. Or there's a keys method, which displays all the keys of a dictionary and so on and so on. There was something else like items, which we found useful when we iterating through the objects and so on. So the basic idea of a method, which is again something we've been talking about before, especially with stuff like strings, for example. There are a bunch of string methods we talked about, like method for finding a substring or method for replacing a substring with another substring and so on. And the methods are functions which are connected to objects. So we call them by using a variable which holds a reference to an object. So basically this means that we want to get the keys from this object in here, which is in practice is this object we're initializing here. So it's different to just calling a function like a len function, which is just where we just provide the name of the function and then the parameters in parentheses or arguments in parentheses. But in this case, we provide the name, or we provide the object, then a dot, and then the method we're calling. So this is something that's going to be important, even more important later today. When we are creating objects, there are some special cases, and these are the ones we've been, or examples of the special cases we've been talking before. So lists, for example, are declared by using the square brackets like this. This is something we've been doing a lot. We've been dealing with a lot of lists because they are really sort of, or are really useful whenever we're storing data. And similarly, we can create a string object by having a string literal inside quotas like this and then storing it into variable. Or we can create a dictionary by using this predefined syntax where we, for each item, provide the key and then the value separated by a colon. Or we can create a tuple by just having the items listed inside parentheses. So this is all familiar. So this is like the way of creating these special kinds of objects that Python supports. But the more general way to create an object is use something called a constructor. And a constructor is a special kind of method we can use to create an object. So if we use the fraction, for example, as an example, let's import the fraction class. So now to create a new fraction object, we just type something like, and then we call the constructor, and then we provide the parameters. So this one creates a fraction of 1/3, and maybe create another fraction, something like 2/5, for example. And now if we output one of these, we can see the content, it's 1/3, but what we're really interested in is it's not the actual fraction, but the how to create an object out of a class. So fraction here is a class. We import the class, it shows there that it's a class fraction. This class implements rational numbers, which and the actual fraction sort of functionality is really useful when you're dealing with values like 1/3, which is difficult to model with floating point numbers, as we all know. So, and when we have access to this fraction class, we can create an object by calling a constructor, and the constructor is named similarly to the class. So this fraction here, it's basically a function. It's a method kind of function, and we call it, and we provide the arguments like we're calling any function. And this constructor returns an object, in this case, a fraction type of object, which we can then store into variable like this, and then we can access whatever operations it provides. Something like, if you want to know the numerator of the fraction, we can use the numerator and find out that it's 1, or we can get the denominator similarly, so it's 3, and so on and so on. So another important concept is that something I probably mentioned before is that objects combine the data and the operations to manipulate and well, to manipulate that data. So in this case, this fraction object provides us, for example, operations which we can use to find out what is the denominator of a fraction, or numerator of a fraction, or whatever operations there are. Okay, now we've been talking about objects before, but we haven't really been talking about classes. I mean, class is something that has been probably mentioned a couple of times, and it was mentioned just like a minute ago, but even in the first course. But it's something we're going to talk about a lot more in this course. And the basic idea is that class is like the blueprint of the object. It's like the plan of the object. It's something that defines the structure and functionality of objects created out of that class. Almost always it's possible to create several objects out of a single class. There are exceptions for this rule, but it's something we're not going to talk about in this course. But if you're interested, there are exceptions, something called like a singleton class, where you can only create one object from. But the basic idea is that we write a class, and then we can generate however many objects we want out of that class. Okay, so again, this is sort of abstract, so let's see how it actually works. So let's write a class of our own, and to define a class, we're going to need a new keyword, which is logically class, and then let's create a class for a bank account. That's something I'm going to start with, and let's not give any implementation to the class yet. Let's just use a pass keyword like we've been using before. It's sort of denotes that we're going to implement this class later. And a couple of things to realize before we go any further. First, the naming of the classes. When we are naming classes, we usually in Python use something called a camel case, where each subsequent word starts with a capital letter. So it's like bank account, the one we use then, or library database with a capital L and capital D, or Python course grades. So it's capital P, capital C, and capital Z in that one. So this makes it easier for us to recognize the classes from, or distinguish the classes from, like variables and functions, which we typically name in lowercase, and then we use the underscore between different words, and so this is the way to name them if you want to follow the standard way to program Python, and you hopefully will follow that. So what it means that we define the class. So as I said before, a class is a blueprint of an object. And when we have a class, we can create an object out of that class. And this actually applies to any class, even if we don't have any implementation for the class. So we just define the class bank account. We didn't provide any code inside this class, but we can still create an object out of it. I can create something like setting account, and then I can create a new object by just calling the constructor like this. So now I created a new object out of the class bank account, which was defined in here. It isn't really usable in this point because there's no implementation, but it's still a valid object. And if we check the type of the object, we can see that the type of the object is bank account. So it's actually a bank account type object. It's not a list, it's not a dictionary, it's not anything else. The type of the object is actually bank account, which already sort of explains on what we're going to do with these kind of objects. So we're probably going to store, well, dates that somehow related to bank accounts to these kind of objects. I can again define any number of classes. Let's create class student as well. And then we can say that Simon is new student like this. One letter over there. So again, Simon, there's nothing really interesting in there, just my student object, and then there's a hash code over there displaying where it's stored somewhere in Python's well, not memory, but somewhere anyway. Okay, so creating classes is easy, but just having a class without any implementation isn't that useful. Let's get rid of students. Let's get rid of this data as well, and let's add some functionality to the bank account. And the first thing we want to add is the constructor. So if we don't define the constructor ourselves, then Python adds something called a default constructor, which we saw in here. We can create objects from a bank account even if we didn't define the constructor ourselves. So we can just use this sort of empty constructor, which just creates an object but doesn't do anything else. But usually when we are creating objects, we want to provide some data for the objects. So if you think about banking, well, what kind of data could be associated with banking accounts? What do you think? What should be useful kind of data that's somehow associated with banking accounts? Yeah, the IBAN code and the credit score. Yeah, definitely. Let's have some. Let's have the IBAN and maybe balance is something that's probably useful. It's good to know how much money you have left if you have any after paying all the electric bills. So let's see how this works. So we write a constructor. It's a function, so we were just defining a new function inside the class. Yeah, and the name of the constructor is predefined, so it's init, but there are 2 underscores before and after the name. And Visual Studio Code actually helps you with this one. If you just click enter, it creates on this sort of empty constructor, but we're not going to use this one. We're going to write it ourselves. And whenever we are writing methods in a class, and especially when we are, or not especially, but when we are writing methods which are somehow connected to objects created from the class, like the constructor is, we start with a special variable called self. So the first parameter is a special variable called self. And the idea of this variable is that we can use it to access the object created out of this class. Like the current object. And I show you how it works. So let's see, we have the IBAN, which is probably a string, I think, because there are special characters in addition to numbers. and then we have the balance, which is float. We could have had the credit score and whatever you recommended, but let's just start with these two numbers, or two, not numbers, but two parameters. And now what we do inside the constructor is that we store the data into object. The data provided as arguments. So we use the self variable and say that self IBAN equals BAN, like this, and self and balance. Now this looks a little strange probably, but I'll explain it in a minute. So what happens here is that this self.IBAN is a different variable than this IBAN here. Whenever we're using the self variable, we are referring to the properties of the current object. So what it means is that we are now storing data into object we are creating. And what we are storing is the value provided as a parameter here. Typically, these are named similarly, but we could name this something different. We could call this like account ID or something, and it's still perfectly valid Python code. But it's a good idea to use the same name as a parameter name and as an attribute name, because that again makes it easier for the client to understand how they are creating these objects. There are a lot of new concepts here, like the attribute and client, which I'm going to explain. Well, the attribute I'm going to explain now. So these self.IBAN and self.balance are attributes of an object. And again, because all objects are independent, each object have their own values for each of these attributes. Has their own, yeah. So let's create a new banking account and let's see how it works. So now we need to provide the values for the IBAN and for the balance. We don't need to provide, and we shouldn't provide the value for self. It's something Python does for you. So you're not providing, you're just providing the values for these other parameters. So let's say that IBAN is something like 1, 2, 3, 4, 5, 7, 8, 9. And then the balance for this checking account is something like 9550 or something. And now we created a new object and also provided some data for that object. And now we can access the data by just using the name of an attribute, which we can see that the Visual Studio Code also recommends. So let's see what was the balance of the checking account, like this. And when we execute the code, we can see it's 95.5. Let's add some money. At 100, and then let's output the checking account again, and we can see that the amount stored in checking account has increased. And now again, as I said in the beginning, all the objects are independent. So let's create another object. Let's create like a credit account sample. Have an IBAN like that, which definitely isn't a valid IBAN, but it's good for our purposes here. And there are 245 euros in the credit account. And now you see that when we output the balance of credit account, oops, like this. Let's do it after changing the balance of checking account. We can see that these two objects are independent. They both have their own IBAN number and they both had their own balance, which is logical because each account has a separate balance from all the other accounts. And when we are changing the balance of an account, it doesn't affect any other accounts. Though this is like changing a list, doesn't affect any other lists. so nothing has really changed in that sense. So by using a constructor, we can provide data for an object in a predefined form. In this case, we have said that whenever you're creating a new bank account, you need to provide an IBAN and you need to provide a balance. We can use default values for parameters if you want to. So this is basically like a function, but it has a predefined name in it, and it's called not by its name, but by the name of the class like this. So this one actually calls this init function in here, which we can actually see if we do it something like this. And just by creating an object outputs the message created a new object. So this is actually a function like any function, but the basic functionality of this function, the functionality of function, is to initialize the object. And the usual way to initialize an object is to store data inside that object. So the self variable is used to access the attributes of this object like this, and then we can store data into those one. And we usually use the parameter values so that when we are creating different accounts, we can set the IBAN number and the balance separately for each account, or whatever data we want to. We can also have other methods inside the class definition. So let's have something like add money, and then again, when we are writing a method that's somehow connected to objects, which is basic idea of what the methods are, we start by having the self parameter, and then we can have other parameters if we need to. And let's say that we want to have the amount of money added. Like this. And what we do in here, we just want to add the given amount of money into the balance. So we say that self.balance, and then we add the money provided as a parameter. So let's see if it works. So let's add 1,000, and then let's output the balance after that one. So it should be increased, and it is. So we started with initial amount of 95.50, and then we call it that money. We added 1,000, and then it's 1,095.5 euros or whatever the currency is in this case. What this means is that since we are adding all these operations in here, we try to make using the bank account as easy as possible for the client. And now the client is something, I think I have a slide about this one. A client is the program code utilizing the class. So when we talk about clients in object-oriented programming, we don't mean like actual clients. We don't mean any people who are buying something or who are using the software or anything like that. But what we mean is the program code which utilizes the class. So in this case, this is the client in here. And the basic idea and basic approach of writing classes is that we provide the necessary operations for the client. So if you just look at the client code in here, the client can now manipulate the bank account by adding money by just calling this method in here. The client doesn't need to know how the method actually works, so what happens in this function in here. The client just needs to know that there's an operation for adding money, and then in real life, we probably need to have other operations like operation for withdrawing money and maybe operation for adding the interest and things like that. But in this case, we just have a single one. Let's have another operation just for the sake of example, something like service fee. And let's say that we don't have any parameters for this one, and it's just like an annual service fee, meaning that we take 10 euros out of the balance. So now when we call this one, and then we output the checking account again, we can see that the balance has decreased by 10 euros or something. And again, it's for the client, it's not important how this works. The client can just call these methods to utilize the object. So to create the object, to see the value stored inside the object, and then use the methods provided within object. And the good thing about this one, and this is something we're going to talk about a lot more next week, is that when we are doing it like this, we can also add some kind of checks in here. We can check that if the balance is more than or at least 10 euros, then let's decrease the balance, and if it isn't, then we don't do anything. So we can't take 10 euros out of an account if there are no 10 euros in the account. Well, the banks actually can, but that's not the topic here. But anyway, so we can do whatever we want inside these methods, and the client is still using the method just by calling them, by using the object defined from the class. So there's a term called encapsulation, which means that we're hiding the actual implementation from the client. It's not really important. The client is just creating objects out of the class and then using the methods. Like we've been using with strings, for example. You don't really need to know how the find method or how the replace method actually works. You just need to know that what is the result. So what are they used for, and then you can use them. And the same applies for all classes. When you are writing a class, it's of course important to know what's happening in here and realize that you're actually doing what you're supposed to be doing. But from the client's point of view, it's not important what really happens inside these classes. You're just using the objects by using the methods provided. You can have any number of methods inside a class, and it's typical to have a lot of them when you have a more complicated class. And for the real banking account, we probably need a lot more variables, like the owner of the bank account and what we have, like the BIC number and the credit score and probably some kind of interest, that maybe a type of a banking account and whatever. But it's an example. Okay, one more thing about today. Now, if we output an object, let's output it here. Let's get rid of all this extra thing and let's just output the object. So if you output the object, the result is this unreadable Python notation, this main.bank account object, that and then this strange hexadecimal number. And this isn't really useful when you're debugging your program or something like that. You can output, of course, the balance and the IBAN number by accessing the fields. So we can do this. But if you need to do this a lot in your program, then it's not really that handy. And we can make things easier by writing a special method inside our class, which is called str. Yeah, and again, we use 2 underscore characters between and after the name. This is Python's sort of way of, well, we're going to talk about this next week more, but this is sort of Python syntax for defining these sort of hidden, well, not really hidden, but sort of like hidden or predefined methods in the class. I don't really like the syntax of having these underscores, but it's not something we can change. So anyway, the str method again gets self as a parameter and nothing else. And what it does, it returns a string representing this object. And in this case, it could be something like, and you can use the F string for this one, it's useful. Let's have the IBAN and then balance something like this, for example. And now when we output an object created out of this class, Python automatically calls this str method. So now when we output in checking account, we get this string defined in here stating that IBAN is this number and balance is this one, which is a lot more useful when, for example, when you're debugging your program and you want to see what's happening inside those objects. So it's easy to just output the object when you have defined the str method like this. And the only rule for str method is that it needs to return a string, but typically we return a string which contains the information about the contents of the current object. This lecture is almost over. Now, if you have any questions, now it's a great time to ask them, or if you want to see something else. I intentionally didn't want to include too much stuff in here. There are a lot of new concepts in here, like the whole concept of classes, and then there are the constructors. There's the concept of variable self, which is new. There are methods, writing our own methods inside classes, and there's the str method as a special case. So if you think that this feels complicated or feels difficult or something, don't worry, it gets a lot easier when you do this again yourself, when you start writing your own classes and so on. But it is somewhat complicated concept, but it's really important concept. It's one of the main paradigms, the object-oriented paradigm in programming, and that's why we spend this week and the following 3 weeks in learning this. Okay, if you don't have any more questions, then I'm going to cut the recording. If I can find the button for